What is up, friends, students, and geometry lovers in general? I hope you all doing well today. Today we are going to have ourselves a fun discussion on classifying triangles, and going to talk about triangles in general, what categories we can fit triangles into, and we're also going to talk about how to describe triangles, sides in relationship to their angles, and angles in relationship to the sides of the triangle, and all sorts of stuff like that. A lot of what you're going to see in this video, and this won't be a terribly long video, a lot of it is what I would consider to be review. Most of what we're going to talk about today you've probably already heard before, either in middle school or in high school. And talking about easy versus difficult, I think this lesson's going to be pretty darn easy. And I think you'll find when you do the actual activity that goes along with it, it's pretty easy as well. So I hope you pay attention to the video. Ask me questions, email me, however you want to get a hold of me. And yeah, let's get this one done, okay? So if you are following along with me to the assignment that I've given to you, this is Chapter 5, Section 1 on classifying triangles, and we are on page 148 is what we're starting with, okay? So before I come up here to the notes, let's just remind ourselves, what is a triangle? The actual definition of a triangle. Well, a triangle is a three-sided polygon. Any three-sided polygon, it's composed of three segments joined at their endpoints. It forms a closed figure, right? And some of the important properties of a triangle, of course, three vertices, three angles, as well as three sides. But also, we know that we've learned that in geometry, anytime you have a triangle, the angles of a triangle always add up to 180 degrees. So those are just some things, some review things that we've talked about before that you'll need to know for this, and I wanted you to remember. So that's the big one. Everything on a triangle, the angles of a triangle always add up to 180, right? All right, so when we look up here, I went ahead and drew a bunch of triangles, and a lot of what you see here, it's in your notes, it's in the handout that I've given you on a Google Classroom. But we can categorize triangles in two different ways, and they overlap each other a little bit as well. We can categorize a triangle based on the triangle's angles, but we can also categorize it based on its sides, okay? Let's look at this first one here. This first triangle here. Now, unless the angles are marked, you don't ever assume something, right? But in this case, we can clearly see that all three angles in this triangle are less than 90 degrees, all right? None of them are right angles. None of them are bigger than a right angle, just by visualizing it, just by looking at it, right? So in that case, if we can look at a triangle and clearly see all of the three angles of that triangle are less than 90 degrees, we call this one an acute triangle. It's an acute triangle. So if you want the definition, we can say all angles less than 90 degrees. Okay, so that's the definition of an acute triangle. This one right here, we can clearly see one of the angles in this is marked with a right angle box. Also, let's say we didn't have this right angle box. Let's say they just said it was 90 degrees, right? Either one works. It does not matter, okay? So in this case, this would be a right triangle. This is a right triangle, and it's the definition of a right triangle is one angle is 90 degrees, right? So far, nothing incredibly shocking. Like I said, this is a lot of review for this section. This one over here, we can clearly see it has an angle that's greater than 90 degrees, right? So in that case, this is an obtuse triangle, right? So it is, the definition of an obtuse triangle is a triangle with one angle greater than 90 degrees. One angle greater than 90 degrees. Of course, you couldn't have a triangle with two obtuse angles in it because the other two sides wouldn't connect. That just doesn't make any sense. So if someone ever said, you know, more than one angle is 90, I mean, more than one angle is more than 90 degrees, that would just be impossible, okay? Plus, that would go over 180, and that's impossible as well, right? 90 and 90 is 180. So if you have two angles more than 90, you got more than 180 degrees, and that's impossible for a triangle. This last one right here is it is kind of in its own category, but it can also be considered an acute triangle. The name we give this is a triangle with all angles the same measure. In this case, it would be 60, 60, and 60 degrees. But anytime you have a triangle that has all three angles the same measure or 60 degrees each, this one is called equiangular. And I realize that's kind of small. You know, I had to fit it in there. But this one is known as equiangular, not equilateral. I know a lot of people try to say this is equilateral, and they are the same. They're in the same category together, but the definitions are a little bit different, right? This one down here, that I'll talk about in a second, this is an equilateral triangle, okay? And I'll get to that in a second. But equiangular, the definition of equiangular is a triangle with all angles the same measure. All angles the same measure, or in this case, they're all 60 degrees, right? So those are the four categories of triangles based on the angle measures of the triangle. And like I said, there can definitely be some overlap we're going to see with these three right here. So, sorry about that. Got something in my eye. Now, the bottom three down here, we can categorize triangles based on their sides, the length of their sides, right? We categorized these four based on the measures, the degree measures of their angles. Well, down here, we're going to categorize these based on the lengths of their sides. Now, if you haven't seen this before, I've put these like hash marks on the sides. This is just a way we can show that the sides are either congruent, they're the same measure, or they're different measures without actually writing down the length of the sides. So in this case, because they all each have one hash mark on each side, we assume or we know that each side is congruent, right? So in this case, this is what I called earlier an equilateral triangle. So this is equilateral. And the definition of an equilateral triangle is all three sides are congruent. So that is the definition of an equilateral triangle. Now, this one here in the middle, we can see this side here and this side here each have the two hash marks on it, which means that these two sides are congruent to each other. But this side only has a single hash mark on it, which means it is not the same measure as these two sides. So this triangle here, by definition, this one is called an isosceles. I-S-O-S-C-E-L-E-S. Now, for all my students out there, I realize I'm not an English teacher, but that's how you spell isosceles. It's in your notes as well. It's on the page, the handout that I've given to you on Google Classrooms. I expect you, when you do this assignment, it should absolutely, wake up, it should absolutely be spelled right, okay? it'd be different if you were having to memorize it or bring it out of your head. But if it's written on the page in front of you, make sure you're spelling it right. I know isosceles is kind of a tricky one, but with any of these words, you know, I expect at least you to work on your spelling, okay? Spelling words correctly. By definition, though, an isosceles triangle is two sides are congruent. Now, here's the thing. So, just to not get confused here, these actually fall in the same category sometimes. They have some overlap. All equilateral triangles, by definition, are also isosceles, because the definition of an isosceles triangle is two sides must be congruent, right? Well, if we look at an equilateral triangle, these two sides are congruent, or these two sides are congruent, or these two sides are congruent, right? Even though all three sides are congruent, it also falls into the same definition as an isosceles triangle. So two sides are still congruent. So it's all equilaterals are isosceles, but not all isosceles are equilateral. I know you probably just went cross-eyed on that one, so don't think about it too much, but it's just a fact that I wanted to give you. All equilateral triangles are also isosceles, but not all isosceles are equilateral. All right? The last one here, the last one we're going to talk about. This one has a single hash mark down here, 2 over here, and 3 over here. So it has been indicated that all three sides are different measures. And in that case, we call that scaling. So this one is a scaling triangle. S-C-A-L-E-N-E, if you can't read that. And then that is no sides are congruent. Okay. Like I said, all of these definitions are in the handout that I've given you, but I just kind of condensed it a little bit to make it a little bit easier. All right. So if you need to pause at this time just to kind of either highlight your notes that I've given you or write these down separately, please do that. But let's talk about the very last thing that I want to discuss from this lesson, and then you're done. Like I said, this is going to be a shorter video than normal just because a lot of this is review, and even if it's not review, it's not terribly difficult stuff. Okay? So let's talk about the angles and the vertices in one triangle. Or how can we navigate the triangle? Maybe that's a better way to talk about it. How can we navigate or talk about the parts and the directions of a triangle and all that stuff? So check this out. Let me get this off of here. So I'm going to just draw a random triangle up here. Also, just a friendly reminder, when we draw, we use an actual tool, right? A sketch is when you just do it free-handed and it's not really that important. It's just kind of a rough drawing. An actual drawing, you use a tool, and then a construction is the most specific, and that's when you get actual measurements and you put some time and effort into it. We're not going to do a construction right now. So I'm just going to draw a triangle up here. And we'll say this one is a scaling triangle, because all three sides will be different, and I'm not going to really measure anything out specifically. So we'll just say this is a random scaling triangle, okay? And I'll label this X, Y, and Z. Okay, so this is triangle XYZ. Get out of the way for a second. All right. Let me check that out. Okay. So if we look at this triangle, every single triangle has 3 vertices and 3 sides, right? Here's the vertex X. Over here is the vertex Y. And down here is the vertex Z. Now notice I've put different number of arcs in each corner. This corner has 1 arc, this one has 2 arcs, and this one has 3 arcs. And all I'm really doing there is signifying or showing that the 3 angles, get out of the way, the 3 angles have different measurements, right? I just mentioned this is a scaling triangle, so all 3 angles are going to have a different measurement. By that same definition, I can put 1 mark here, 2 hash marks here, and 3 here. Once again, I'm signifying that this triangle has 3 different measurements for sides. None of the sides are congruent. Okay? So, talking about directions and sides. If I said, what are the sides of this triangle? We can label some different things. And some of this is going to seem pretty obvious, but I still want you just to understand what I'm talking about here. So, the sides of my triangle, first are side XY. Remember our symbols, people. That little bar that we put above it, that signifies segment or side. Segment XY or segment YX. Remember, segments don't have direction, so we can call it either one, XY or YX. We have segment YZ or segment ZY. It's the same. And we have side or segment XZ or segment ZX. All right? So, those are the 3 segments that this triangle is made of. Now, it also has 3 vertices. So we have vertices of the triangle. And this one has 3 of them. So we can say angle X, angle Y, and angle Z in this case. Right? So we use that symbol. Now we could go crazy and I could call this angle YXZ or ZXY. And in some cases you can. You know, you can name it from 3 letters. I just thought that would be a little bit, it's just easier in this case to name it with 1 letter because each vertex only has 1 angle at that vertex. Okay? Now, let me just throw a couple more things out to you, and you're going to see this in your assignment for this lesson. And I don't want you to get confused. So everybody's got this, the sides and the vertices, right? I'm going to leave my triangle up here because I want to talk about just some directions or identifying parts of it given other parts. So if I said, what side, what if I ask this question? What side is between angle Y and angle Z, or vertex Y and vertex Z? And they ask you questions like this on your assignment. Don't overthink this one, okay? Don't overthink this one. I'm not trying to confuse you here. If this is vertex Y and this is vertex Z, what side is between YZ? YZ. That's it. That's the answer. What side connects the 2 vertexes? That would be side YZ. Okay? So without even looking at this drawing of this triangle, you should still be able to figure it out. If I have vertex Y and vertex Z, what side connects them? Side YZ. Okay? If I said something like this, once again, I'm not trying to confuse anybody. If it seems obvious, it probably is obvious. Okay? If I said, what vertices are connected by side, I don't know, XZ. So, what vertices are connected by side XZ? Okay, what vertices are connected by side xz? Don't overthink it. It is as simple as, and I'll switch up the color so it doesn't look like a big black mass. It would be x and z. Angle x and angle z. Don't overthink it, okay? The last thing I want to talk about here, and then I'm finished. It's the same ideas. We talked about this back in chapter 4, previous semester, but I just want to remind you of it. Every side has an opposite angle or vertex, and every vertex has an opposite side. So if you got these two down, I just want to remind you about opposites. And I'm just going to draw them. So looking back at this triangle one last time, we can see, let's start here with vertex x, or angle x. Okay, you know what, I don't even need the ruler for this one. If I'm starting here, across or opposite of x is side yz. Opposite of angle y, and then, so what I'm saying is that, and it's kind of hard to see that on my screen, sorry about that, but angle x or vertex x has an opposite side of yz. It's the one directly across from it. Angle y or vertex y has an opposite side of xz. And if I started at vertex z or angle z, directly across from it is side xy. So every single vertex or angle has an opposite side from that vertex. Okay. And I don't know if you knew this or not, but if these were medians, this part right here in the middle where all the medians meet up, we call that the, which I'm not going to ask you about this, but it's just more or less a little math fact. Where all these medians meet up in the center, that's called a centroid. Centroid. So, like I said, we're not finding the centroid, and I'm not asking about that, but it's just another fun math fact that, you know, you probably didn't know about, and if you did, that's awesome. Okay, so that's kind of how to navigate yourself around a triangle. For this lesson, people, let me pull it up just to remind you. You will be doing, where you at? For geometry, your first lesson on this one, this is chapter 5, section 1. Just to remind you, I'm asking you to do all odd problems from 1 to 35. So odd problems 1 to 35, and that's on pages 151 and 152. The lesson's already up. I'm looking at the Google Classroom right now. I can see some people have already started working on it. That's awesome. I appreciate that. I'll post this video very shortly. And then also Chapter 5, Section 3, which is the follow-up lesson, I'll try to post a video on that today as well. So you all can get at least a couple of lessons knocked out today. And as always, if you got any questions, you know how to get a hold of me. I'll post that in the description of the video. You can call me, text me, message me, email me, anything that is convenient to you. I'll be checking them all day. Other than that, I hope you're all staying safe, staying healthy, staying somewhat happy, although kind of cramped. Get outside as much as you can. Try to take it easy as much as you can. Play some video games. And like I said, we'll get through this together, okay? Hope you're all taking care, and I'll see you. Bye.